Hello, I am Dr. Gajendra Purohit and you are watching our YouTube channel where I upload videos for engineering mathematics B.Sc students. Today, about 3.5 years ago, I had created numerical analysis where on the green board I presented all the content to you all. In that, I had used the Newton-Raphson method. Iteration method, secant method, bisection method, numerical integration, interpolation, numerical differentiation. Very good videos were uploaded. I had shown how to solve differential equations by numerical analysis. Very good work has been done, but I felt that there is some more content that can be improvised. So students, I am going to re-upload the numerical analysis series back and it will be called 2.0. Inside this, I will upload one by one all the topics as I started with error analysis, which was not in my old series. After that, operators are there then, interpolation, equal and unequal intervals, numerical differentiation and numerical integration. After that, the topic of difference equation was not uploaded on our YouTube earlier. We will also work on that. So the entire content of numerical analysis, we will try to provide it here. So students, in today's class, we will focus on error analysis. What are the types of errors that exist and how we analyze them using numerical analysis tools, right? Students, let's start. We will talk about error analysis. The numerical error is the difference between the exact solution and approximate solution. Whenever we solve any differential equation using a numerical method, or when we solve any integration with the help of numerical method, or we interpolate any data, we get an approximate value and not the exact value. Clear, students? So whenever we try to calculate the difference between the exact value and the approximate value, obviously there will be some error, right? And we are doing the analysis of that same error here. Now there are types of errors. The first one is called inherent error. So what is inherent error? That is already given in our data. For example, if you are given some data, like let's say X here is the year and here is the population. Let's say this is the population we have, let's say 1981. 1991, then here we have given 2001, 2011 and 2021. Right, students, clear? So students, here assume that you have this population data, which is for year X. In this year, the population of a particular place was 10 lakh, right? I think it was 10 lakh 50,000. Then here it is given that 11 lakh is here 52,000. Then after that it became 13 lakh, right? And then here we have 14 lakh 50,000. And then here 17 lakh came. We have a given data that in this year, this was the population, okay? But exactly it won't be 11 lakh 50,000. There has to be some data, right? Like 11 lakh 50,000, 315, something like that. And here as well, what we did, like we did approximate, right? Let's say if we look at the 1991 population, we wrote 11 lakh 52,000, but it should be 11 lakh 52,000, 203 or 304, something like that. So what we did with the previous data, we did what? We approximated it. When we do analysis of any data here, let's say we tried to find the population. What will be the population in 1982 or you are told in 2000? What will be the population in 20 or the population in 2009? So whenever we do analysis of any data, obviously the approximation that we used here, because of it, it will lead to some error in the calculation, right? So the error that comes in the calculation is called inherent error because the data we took had the error in it. Because of that, the final answer that we will get will also have error somewhere or the other. That error is known as an inherent error, right? You need to understand this. If I were to explain to you, inherent error exists in the problem either due to the approximate data given, limitation of the computing aids, such as mathematical tables, desk calculators. Such type of error can be reduced by taking better data. If we want to reduce inherent error, we will take exact data here. So the error we will get will be minimal. But whenever we take the exact data, there are a lot of calculations, right? For that, somewhere we should use such softwares that can help us reduce this error. We are talking about round of error. The term round of error itself suggests that, let's say we have a number like 1.24372. We are writing it as 1.244. So actually here, this is the exact value and we approximated it here. So the difference will be 0.00028. This is known as a round of error. Here, this is round of error. Now you will say that the inherent error and round of error is same. So the inherent error that occurs, it happens with the particular data we have. Then we calculate it and get the final answer. The error that occurs because of that, it is an inherent error. Here if we are talking about round of error, what does that mean? Let's say you calculated the population in 1982 and the population was 11,25,255. Here you have done 11,25,000 and left the data behind, you approximated it. So here you have rounded off the calculation done, right? Final answer was rounded off. So the error that will come will be round off error. This is something you need to pay attention. Next we will discuss chopping. So chopping means exactly the same here. In chopping, the extra digits are dropped. We don't round off there, we just leave the further digits. For example, let's say we have a number given 546.25. Now what we did is we removed the point from the end, meaning we removed the 5 from end. Is it clear? Now see, we have done chopping here. After 4 digits we did chopping. If we remove 5 from the back, due to that the error that we are getting is 0.05. Like we have this number. What we did here, student, is we have chopped the number after the 4th digit, meaning we have removed 589. So the reason we have error is this error, right? So chopping means we don't round off. We just remove the digits. You will be told that to chop after the 4th digit or 5th digit. So take the first starting 5 digits. Then after that, remove the remaining data after the point. That is called chopping, okay? The error that comes because of this, that error is known as chopping error. So next we talk about what is a truncation error. Whenever we have any transcendental function such as e to the power x log 1 plus x sine x cos x tan x, what do these have? They have a series. Like we have e power x, its series is here, right? But if I tell you that this is the series for e power x, so we approximated e power x to 1 plus x. So here what I did is I left the higher order degree terms, I truncated it clear, right? Truncation means that the term is deleted or removed. Okay, students? Right, so we have truncated it clear. Now, if by chance I put x is equal to 1 here, so the value of e to the power of 1 here will be approximately 2. And while we have the exact value of e power, that is 2.71828, this is the exact value. Here you see this is the approximate value and this is the exact value. So the difference which is between them, that error is known as a truncation error. So we call it truncation error. Clear, students? Next concept is known as absolute error. What does absolute error mean? So the difference between the approximate value that we have here and the exact value, the modulus value of that difference, or we can say it's absolute, meaning whatever difference is there, we will take it positive, right? That error is absolute error. The absolute error is the positive difference between actual value and approximate value. That means we'll put a mod ahead, right? We'll denote this using del x. There is relative error and we don't have to do anything. So absolute error that we have divided by the exact value that we have here, assume that the exact value we have is x. Okay, students, now. And this is called as its absolute error. We take the ratio of both. That is known as a relative error. One is percentage error. What happens in it? What do we do? Here we are given this, multiply it by 100. So what is this called? It is the percentage error. Clear? So you need to understand this. So students, we have absolute error. It is the positive difference between the exact value and the approximate value. So the ratio of absolute error and the exact value is known as relative error. And if we multiply it by 100, then it becomes percentage error. So you need to understand it. I have tried to explain it to you. I've also explained the percentage error here, right? Where we calculate percentage error, if you are asked about any error like relative error, then we have concept of total partial differentiation, that u is a function of x1, x2, xn. Here we are doing partial differentiation. Here it is del u by del x1 into del x1, del u by del x2 into del x2. By this type we calculate this. I will take some questions so you will understand it better. Let's say we have an example. What is it saying? So find the relative maximum error in the following function. We have u is equal to what here? Here u is given as u is equal to 7xy upon z cube. Here what do you need to calculate? It's relative error. That means what do you need to calculate here? Del u upon value of u. Clear? Whenever we have such a question given, then we have del x, del y, del z and x, y, z are given. Whenever we have this type of question, apply log to it. It will be easier. What will we do? Here we take log on both sides. What will come? Log u is equal to log. This will come 7xy upon z cube. I have explained it in a different way. You can see that I am telling here. That's one way as well. Ultimately, we're doing the same. We took a direct log, right? So listen here this. Here, this will be log u is equal to log 7 plus log x plus log y minus log z cube. Clear? You understand? This is the product, right? So, the product will come in plus and what comes below will be in minus. So, Let's make this a little more systematic. Log u is equal to, this will be log 7 plus, here we have log x, right? Plus log y, and we take this 3 out. Then log z will come. Now what we do is we partial differentiate this with respect to u. This will be del u by u. We partial differentiate each one, right? Here if it's 7, this will be 0. What is the partial differentiation of x? It's del x upon x. What will we get here? It will be del y upon y. Then it will be minus 3 del z upon z. Here we have to find value of del u upon u. You need to understand one thing. You are being told to find relative maximum error. Sometimes it can be asked to find the error, relative error. So you need to put the value of these here, del x, del y, del z, and x, y, z, and you will get the answer. If we talk about maximum relative error, then what will we do? We will take the modulus. When we take modulus of this, it will go in front of everything, del x upon x plus, this will also have modulus. So this will become del y upon y. Here modulus will be there. So because of the modulus, this minus which will come, here it will become plus, you need to pay attention. So the modulus of del u upon u will be 0.001 upon 1 plus 0.001 upon 1 plus 3 into 0.001 upon 1. So you can see 0.001, 0.001 and 0.003 will come. So from here we have the value that will be 0.005. So this will be our maximum relative error. So this is how we do this question. Clear, students? There is another thing that need to be understood. So when we will read further, this is a concept that here we use the Lagrange interpolation concept for the unequal interval when we interpolate any data, right? We can use it for equal intervals too, right? But normally it's for unequal intervals. So there is also the concept of error. So what is that? If we have a Lagrange general interpolation formula, so its error formula is 1 upon n plus 1 factorial, right? X minus x0, x minus x1 up to x minus xn, fn plus 1 will be xi. If we have linear interpolation formula here, then we'll have 1 by 2 factorial x minus x0, x minus x1 double order derivative xi. If we look at the quadratic interpolation formula, then here another term will be added and it will be triple dash xi. Clear? In exams, these type of questions can come. I've seen questions on it in some books, so there have been questions on this topic, so it's an easy topic. But formula based questions comes, so you can do it easily during exam. I'll give you an example. Students, I want to tell you that if you are preparing for the CSIR NET, IIT-JAM or GATE exams, then our books are available on Amazon. You can buy this from Flipkart as well. It is available on Flipkart. You can find the link in the description. So next question, see here, which is based on Lagrange concept. We will determine the step size that can be used in the tabulation of fx is equal to sin x in the interval from 0 to pi by 4 at equally spaced nodal points so that the truncation error of the quadratic interpolation is less than 5 into 10 to the power minus 8. Find value of h here, which is step size. Then what should you do? You want to find value of h and you are told that quadratic interpolation is less than this. Meaning from here we have the value that's coming, that is e2fx. It should be what? It should be less than 5 into 10 to the power minus 8, right everyone? In that case, what will be the value of h? What will we do? We will calculate value of this here. Then we will put value of this here. Then we will get the value of h from here. We have the quadratic formula here. So what is the fx given here? This is given, we have to differentiate it 3 times. So students, one time if we differentiate f, then we get cos x here. If we take double order derivative of this, it will be minus sin x. When we take triple order derivative, it will be minus cos x. So listen, the value of f triple dash which we have will be minus cos x. Now you need to understand this. Here it is being said that the value of quadratic interpolation is less than this. So by chance, even if we calculate its value and calculate its maximum value as well, this will still be smaller than this value. We take the maximum of this, then its modules will be taken, whose value will be 1 by 3 factorial in formula. We'll put the modulus and on this one also. Now we know that the cos x is minus. What is the maximum value? Maximum value of cos is 1. So here we will put the value of it as 1. Okay, what will we have here? If we are going to write it down, then it will be e2. Here this will be fx is less than equal to 1 by 3 factorial, meaning 1 by 6. And this will be x minus x0 because obviously the modulus is here with us, right? And x minus x1 and x minus x2, so its value will be this mod triple dash x, meaning the cos x we have here, the value of cos x will be 1. Clear now? Do you understand? We can write it like this, right? Now we know that here they are equally spaced, right? If we look at the data, we have x0, x1, x2, x3, right? This is the data we have. x3 is not there. We only have data up to x2, which means their difference is h, right? If we look at the value of x1 minus x0, it is h. If I talk about x2 minus x1, the value we have here is h, right? You all understand this here. Now what we do is we use this concept here. What I do, here the x minus x1 I convert it. What I do is x minus x1 upon h, I've assumed it as t here. So it means x minus x1 is equal to what here? It will be th. From here the value that we will get will be what? Less than or equal to 1 by 6, right? If we look at this value that we are getting is th, but we need to find x minus x0. So the value of x1 that we are getting here, what is it? If we look at the value of x1, then from here value of x1 will be h plus x0, right? So from here we have x1, the value is h plus x0. We got this x1, directly we put it here. So it will be x minus h plus x0. This will be like this, right, students? It will be equal to th. Here we will take this h to the other side. This will come to us, x minus x0 is equal to th plus h will come. And if we take here h common, then we will get t plus 1, h will come. Now what will we do? We need to find value of this. So we find the value of x1. The value of x1 will be x2 minus h. We take this x1 and we place it here, right? So from here we have x minus, here we have its value will be x2 minus h is equal to th, right, students? So here this will be x minus x2, minus minus will become plus, this will be plus h is equal to th. So the x minus x2 value will be, it will be th minus h. If I write this, then x minus x2 is equal to, from here we take h common, so t minus 1h will be there. Now this value I will put here. From here the value which we get what will be the value of x minus x0. So value of x minus x0 is coming t plus 1h. And here what is coming here? th is coming, right? So here the value of this, what will be the value? T minus 1h will come, clear? Here we will have the value of this. So this will come 1 by 6, t minus 1, t plus 1 and this t. So what will we do? Here this will come t into t square minus 1, this a plus b will be into h cube. Now what do we have to do? We have to maximize it. We should figure out the point for which value of t is getting maximized. What we do with this function? Let's call it f. This question is tricky, but sometimes it happens. So I call it as f. F is equal to, let's use g as f is taken, let's call it g. G is equal to, I took t into t square minus, so I will multiply it by this. This will be t cube minus t. What are we going to do? We'll find the del g by del t. This will be 3t square minus 1, will keep it 0. So the value of t will be 1 by root 3. 1 will go over there by dividing, we take root. So 1 by root 3 will come, right? We will take value of t here and put it here. From here value will be 1 by 6x. We will put 1 by root 3 here. From here we have this, it will be 1 by 3 minus 1 into. Here this is h cube, clear? What will we do with this? We will simplify it. So this will come to us 1 by root 3 and its value will come 2 by 3. So it will be of minus, but this is modulus. So there is no need to worry. Now we have this value is less than or equal to this. What will we do? We will make it less than here. 5 into 10 to the power minus 8, because here we have to calculate value of h cube. So h cube is less than equal to, take this all above and cancel it. So we will get 3. 3 3s are 9. So 9 root 3. It will go up and then multiplied by 5 divided by 10 to the power minus 8. And when we take the cube root here, here we have the approximate value of h. It will be 0.009. So meaning here, if we take the value of h here, but then the error we will get will be smaller than this, clear, students? We can solve this question like this. Next question. Here del x is equal to this and del y is equal to this. Be the absolute error, and x and y value we are given. Then find the relative error in the computation of x plus y. It is saying that if we compute x plus y, what is its relative error? So call it as z. So z is equal to x plus y. Now what will we do with this? We will take log on both sides here. I will take log here. Now we differentiate this. It will be del z upon z. When we differentiate this, it will be del x plus del y upon x plus y. We will get this here. So you need to understand this, okay? Now what are we going to do here? Since we need to calculate relative error, we need to calculate value of del z by z itself, right? From here, what will we have? This del x value, what is it coming? 0.005 plus 0.001 divided by, we have the value of x as 2.11 plus 4.15 will come. We will calculate its value. Then this will be 0.006 divided by. This will come to 6.26. Now we will calculate this. So here the value we will get will be 0.0009, right? Do you understand, students? So what will we have here? It's relative error, right? Let's move on. Moving on the next question. The period of a simple pendulum T is equal to 2 pi root L by G. Find the maximum error in T due to the possible error up to 1% in L and 2.5% in G, meaning the percentage error in L, that is given here, meaning value of del L upon L into 100 is 1. And here the del G upon G into 100, its value that we have is 2.5. You are being asked what is the maximum error here. Find the maximum error in T, right? So you need to find the value of del T here. How much it will be? So what we will do, the same on both sides. We will take log in this formula. So log T is equal to here. We will get log 2 pi root L by G, right? So the formula we have, what we did is we took log on both sides. So students, here you can see this will come to us log T is equal to, this will come log 2 pi plus log root L minus log root G. Do you understand? So root L upon root G will get minus, right? Now take this 1 by 2 outside here. So this will be our log T is equal to log 2 pi plus 1 by 2. Understood. It will be log L minus 1 by 2. Log G clear. Now we'll differentiate this. Pay attention. So this will become del T upon del T. This will become 0. Plus this will be 1 by 2. Del L upon L minus 1 by 2. Del G upon G will come. Clear, students? Because here we are getting maximum error. The minus that is here, we will take the modulus and remove the minus. Clear? So students, here what will come? Del T upon T is equal to, this will come. Okay? We have 1 by 2 del L upon L, right? Understood, students? Plus this will come to us 1 by 2. It will be del G upon G. That's it. Clear? Since we have percentage error here, what I'll do is multiply it by 100. So del T upon T into 100 is equal to 1 by 2. So this will be del L upon L into 100 then, and plus 1 by 2. So here students, this will be del G upon G into 100 will come. We will take 100 inside later. So the value we have is what? It's del T upon T into 100 is equal to. Here the value that we'll get, that is given as 1 and this is 2.5. Take out common of 1 by 2 and here we have 1 plus this, which is 2.5, right? Here we have value of this given. So here del T upon T into 100 is equal to, from here we will get the value of it as 3.5 upon 2. Understood? So students, the answer we get will be del T upon T into 100, which is equal to 1.75. So we have percentage error, right? 1.75, what is that? Percentage error. Here in this question, there is a correction. It is asking you to find the maximum percentage error in T, right? Pay attention to this and this is how we will do it. So next question, see what it is saying. A balloon is in the form of a right circular cylinder of radius 1.5 meter and length 4 meter and is surmounted by the hemispherical ends. So students, here is a cylinder and here we have a balloon and from here as well another balloon is given. Right? Understood, everyone? So we have the radius given here. It is 1.5, right? Here the height which is given, it is 4, right? And apart from this, there is nothing else given. If the radius is increased by this 0.01 and length is increased by this, then we have here value of del R, which is given 0.01. And del L is the value of length, which is given as 0.05, or we can take it as del H. That would be better. For length, we will use H here. You are being asked to find the percentage change in volume, which means you need to find the value of del V upon V into 100. It is asking this. Clear, students? You need to pay attention to that. Here we have the volume of a cylinder and then a hemisphere and a hemisphere. So we will get the total volume of sphere. Students, if we look here, then V is equal to, we know it will be pi r square, H plus 4 by 3 pi r cube. Here what will we have? We will have its formula. Here what will we do? We will take the log of this, right? So this will be log V is equal to log. This will become pi r square H plus 4 by 3 pi r cube. Clear? Here we will have its value with us. Now what will we do? We will do the partial derivative of this. So this will be 1 upon V and this will be del V is equal to, for this, it will be 1 upon, pay attention, this will go down. This will come as pi r square H plus 4 by 3 pi r cube, and listen, we will take the derivative of this here. So here we have both r and h as parameters. So we left pi, we did this. So this comes to be 2 r h del r. Plus then we left this and we did this. So pi r square del h will come here, right? Then we will do this here. So now what will come here? 4 by 3 pi and this 3 will be outside. So 3r square del r. Clear? And this will be the value, right? Do you understand this, students? So what are we going to do? We have the value of del V upon V is equal to, from here we have something common, look from top. What is common in this? Pi r is common, I think pi r. Yes, pi r is common. So what do? I will take out pi r as common. I took pi r as common. So here I took pi r as common. So this will come to us 2h del r, right? Okay, students. And from here we have taken pi r as common. So here it will become r del h clear. So from here this will come. 3 to 3 will get cancelled and r will come common. And pi will also come in common. So this will come as 4r. Del r will be clear. It's divided by, from here we take the pi r as common. If you take out pi r as common, then from here this will be rh, right? And also from here if we take out pi r as common. So students, here this will come to us as 4, right? And here r square will be upon 3. Clear, students? We will get value of this over here. Pi r to pi r will be cancelled out. What are we doing here? We are calculating the percentage error, right? So it will be del v upon v into 100. Multiply both sides by 100. We'll put the value here. What should we do with 100? Multiply it, right? So here this 2h, so the value of 2h, what are we given? This is given here as r, this is given as h, the rest of the values are given, right? So 2 into h, this will be 4 into del r, what is the value of del r? 0.01 plus r. The value of r is given to us as 1.5, right, students? Del h, the value of del h is given as 0.05, right? Plus, students, this 4 and the value of r is, r we have here is 1.5 given, right? And del r is, the value of del r is 0.01, right, divided by, and from here we have r into h. Clear? The value of r into h will be 15 into 4, meaning will be 6, plus 4 by 3. In this, the value of r will be 1.5 whole square and into 100. So when we calculate this, what will be the answer? The answer will be 2.39%. So in this way, we can solve this question very easily here. In comment box for this question here and how long did it take you to solve it, please comment and let me know. You can check previous numerical analysis playlist here and watch them here. If you are preparing for CSIR NetGate or IIT-JAM exam, I have done a lot of work. You can go here and see. Subscribe to the channel here. Thank you all very much. Thank you. Bye-bye.